Here we have to consider that the torque which is produced by a magnetic field on this current carrying coil is compensated by the torque which is produced by uh, force exerted by air on the other end. So we can find out what about the value of this torque which is exerted by the air over here. So assume that this air is sitting over here with some velocity which is given as nothing but v, and consider that after collision its air is coming to rest. So we can find out the value of force exerted on the surface by using the equation, that is force equal to change in momentum or rate of change of momentum, and change in momentum we can take it as something but m into v, because final velocity is 0, initial velocity is v, so this change in momentum is m into v divided by t. Now we can calculate it for a small mass, let's say dm, exerted by a small part of air. So you can write the value of this f will be equal to nothing but dm into its velocity v divided by dt. Now you can find out what about the value of this dm by dt over here. So if you are just considering the cross-sectional view of this particular cylinder, so we can say that the area which is perpendicular to the direction of velocity, that we can take it as having a length that is equal to 2r, and just consider that the width of this small element we are taking as something but dx. So we can find out what about the value of mass of air which is sitting over there. So we can write this mass is equal to density into volume, and volume of that small portion we can take it as nothing but area into length. Area we can take it as nothing but 2r into dx into the length or the distance which is covered by the air molecule. So let's say that is nothing but dl or l divided by time dt into its velocity v. So you can write the value of actually this much term is representing nothing but dm, and if you are finding out the value of dm by dt into v, that will get the value of f. So you can write the value of this f will be equal to rho into 2 into r into dl by dt, that we can take it as v, so it becomes v square into dx. There is various force which is acting on a small element dx. So if you'd like to find out what about the value of torque with respect to its center, so we can just consider that a small element over here which is at a distance x from the center, and its width we are taking as something but dx. So we can find out what about the value of torque acting on this small element. Take it as something but d tau is equal to nothing but force into perpendicular distance f into x, that will be equal to rho into 2r into v square into x dx. And we have to find out the value of net torque. So it is that we can take 2 into rho r into v square into integration of x dx, and in question it is given that the value of or the region in which the force is acting is changing from L by 2 to L. So we can take it as it is 2 rho r into v square into x square divided by 2, and the limit is changing from L by 2 to L. So we can write this as equal to rho r v square into L square minus L square divided by 4. This we can take it as rho r v square into 3L square divided by 4. So the value of torque we can take it as rho r v square 3L square divided by 4. Now we can equate this to the force or the torque which is exerted by magnetic field. We know the equation for torque, that is equal to m cross b, and m is equal to I into a, and area we can take it as something but pi r square into b, and here it is given that n number of turns, so we can write into n. That will get the value of that should be equal to rho r v square 3L square divided by 4. So we can basically find out what about the value of this current I over here, which is I into pi r square into b into n is equal to rho into r into 3l square divided by 4 into the value of v, which is given in the question, which is which we can guess to v square over here, which is 4l square into pi r square b sorry, it is pi r b divided by rho. So we'll be able to cancel this rho, this l square, 4, and this b, and this pi. So we can find out what about the value of n over here. So you can write sorry, the value of I over here. So the value of I, we can take it as nothing but this r also we can, r square also we can cancel. So this will be remaining term is 3 and n, 3 by n basically. So the value of 3 and n is given as 300 over here. So we can write this will be equal to 0.01 ampere.